Hello guys, I hope everybody is able to hear me out. Yes, can you give me a quick yes if everyone is able to hear me out so that we can quickly start the session? Yes, I guess everybody is able to hear me out. Can I get a quick confirmation? Okay, perfect. So hit like before we start. I joined 5 minutes earlier, so we'll wait for uh you know we'll wait for some time so that everybody joins and then we can probably start. Okay. So I hope everybody is able to understand whatever I've taken in the past two classes. Today we'll be continuing the day 3. Okay. And again, we are going to learn something in NLP. Okay. So I've seen some people doing cheating in the quizzes. They're editing and they're saying they're editing in the console and basically writing, okay, they are first, and they're sending me the screenshot in Instagram. So this time after the quiz competition, you also have to send your ID proof. Okay, once any ID is fine, like PAN card, just send the photo along with that. Send the rank that you basically have. Okay, but I saw many people doing extremely, this, for money anybody can do anything. So I have to really take this precaution now. They don't want to even participate properly, and they want to say that okay, I have done this that. Okay, perfect. So I think we have covered a lot of things initially, and we have learned so many things in the past two classes. And what we will do is that today we'll try to learn bag of words. Bag of words is almost completed. TF-IDF will try to learn, and again with by saying some good examples, I'll try to explain you. But before that, I really want to announce one batch that is going to start from tomorrow. You know, that is the full stack data analytics batch. Again, the link is in the info given in the description. So we are basically starting the data analytics batch. Let me just share the screen and show it to you so that you do not miss this. So this is the full stack data analytics bootcamp that is going to go, and the cost of the course is somewhere around 4,000 rupees. And this is starting from tomorrow. Every Saturday and Sunday, the classes will be between 8 p.m. to 11 p.m. Okay. And yeah, so you can, if you are interested, you can join this batch. And again, if you really want some discount, you can use my coupon code Krish10 on top of it to get 10% discount. Okay. So in this, we are trying to focus on if you're planning to become a data analyst and all. So this course will be super beneficial for you. We have 3 mentors, Krish, Naik, Jayant, and Sudhanshu Kumar. Sudhanshu and myself will be the main mentors, and remaining all, I hope there will be doubt clearing sessions, Skype support, and many more things. And this comes with placement job assistance program. Now, this job assistance program through iNeuron job portals, you'll be able to apply for jobs and you'll be able to participate. Okay. So yeah, all the information is given in the description of this particular video. You can definitely check it out. And if you're interested, you can also go ahead with the course. Now let's go back and let's start learning. So today is the day 3. So day 3 of NLP. Okay. So agenda will basically be, again, I'm just going to revise you bag of words, which was left in the previous class. Anyhow, I had also shown you practical. So bag of words is 1. Okay. And the second one that we are probably going to learn is something called as TF-IDF. Third, practical implementation with the help of Python and NLTK libraries. And after that, we are also going to have a quiz. Okay. So quiz, again, the first prize winner will be somewhere around 2,000 rupees. Second one is 1,500, and the third one is 1,500. Okay. So all these things are there, and yeah, let's see whether it'll take 1 hour to complete. I guess it may take 1 hour to complete, and we'll try to complete it as soon as possible. Okay. And then again, I have a quiz for you today, again, related to NLP, and some part of machine learning will be there. And if you are new to this channel, please make sure you subscribe the channel. And don't forget to subscribe Krish Naik Hindi YouTube channel also, because there also I started uploading data science in Hindi. Okay. So if you can give me a quick confirmation so that we can start. Just give me a quick confirmation so that we can start learning things, and that'll be quite amazing, right? So just give me a quick confirmation. Should we go ahead? If you want to share to your friends, please do share. And once everybody's ready, we'll start participating, right? Okay, perfect. Just give me a second. Yeah, let's go and let's start learning things. Okay. So yesterday, I mean day before yesterday, I started regarding bag of words. So again, I'm going to revise quickly. So bag of words was again a technique to convert text into vectors. So if we have any specific text, and if we really want to convert this into vectors, so we can definitely use bag of words. And inside this, suppose if I take an example of some sentences or some documents, let's say my sentence one is like, he is a good boy. Okay. He is a good boy. He is a good boy. Sentence two can be, she is a good girl. Okay. And sentence three can be, boys and girls, or I can write boy and girl are good, right? So usually in this particular scenario, first thing is that what we do whenever we want to convert this, first of all, we try to apply stop words. Okay, what it will be, stop words will actually help you to remove all this unnecessary word like he is, a, she is, right, and are, right? Along with that, we'll also be lowering the keyword so that we don't get repeated keywords in different manner. Because if I write capital good and small good, this both are same only, right? So we need to have a small letters so that we'll be able to understand the text over there. Okay. So what we will be doing, first we'll apply stop words and lowering of the words, and then after we apply this, what will happen is that we will be getting the output which will look something like this. So my sentence one will now become something like this. So after applying this, my sentence one will, he is a, will get removed. So we will be only left with good boy. Okay. Similarly, sentence two will be left with good girl, right? Good girl. And sentence 3 will be left with something like boy, girl, good. Okay. So this is what we will be left with. Now, if I really want to convert this into a bag of words, there is a simple process that we are going to apply. So this is my first step. This is my second step. Now coming to the third step, what will be happening in the third step is that we'll try to just compute the frequency of the words, right? So how many unique words, and this is basically my vocabulary, right? Vocabulary, which are the important words that we are actually trying to focus on and try to create all these things, right? So in this vocabulary, what we are actually going to do is that we are going to write the important words. One word is good, one word is boy, and one more unique word that you can see is something like girl, right? And now with respect to these words, we are going to just calculate the frequency. Okay, what is the frequency? How many good is present? 1, 2, 3. 3 goods are present. How many boys are present? 1, 2. So if I go and count it, it is 2 boy. Okay. And then you can see over here as boy, girl, how many times are present? 2 counts, right? So we are going to basically do this. And then the next step, after you compute the frequency with respect to each and every words, this is what is going to happen to our features nest. So in the fourth step, I will be defining like this: feature 1, feature 2, feature 3, right? And this will be sentence 1, sentence 2, and sentence 3, right? So feature 1, obviously, you know, it is good. Okay. Feature 2 is boy, and feature 3 is girl, right? So with respect to this, I'm just going to define the words over here that are actually present. So good, feature 1, boy and girl. Now you may be telling that, okay, Krish, boy and girl are having the same frequency. Then what may happen is that based on alphabetical way, this can be arranged. Okay. So B usually comes before G. So over here with respect to alphabets, you can see over here I've put it. Now with respect to sentence 1, we will go and see what words are actually present. Here you can see good and boy is actually present, right? So wherever good is present, that will become 1, and remaining all will become 0. Boy is also present in the first sentence, so here you can see 1, right? Then apart from that, if you go to the sentence 2, here you can see good, girl. So good is basically present over here, 1. Boy will be 0 and girl will be 1. Okay. And in the last case, you can see all this are 1. Okay. Let's say if now what are the advantages and disadvantages, which I'll try to repeat it again in this, that over here you can basically see that either you are getting ones and zeros. Okay. Now when I say ones and zeros over here, most of the time this will, like in this particular scenario, you just have 3 words in the vocabulary. Now just imagine if you have 50 to 100 words or 100 vectors. So this is basically getting converted into vectors, right? Now just imagine if you have somewhere around 50 words in this, then what will happen? Your sparse matrix will actually become very bigger. So because of this, the computation will not be very smoother. You know, it will take time for the computing part and all. This is one of the issue. The second issue is that out of vocabulary, right? Out of vocabulary. Suppose if any word is there in this specific sentence, right? Let's say there is also something like cat. Now cat is not there in the vocabulary. Now if we really want to represent in this particular vector, what will happen? This will get removed, right? Cat will just get removed if we get cat in the new sentence, right? So over here you can basically see that, okay, there are a lot of problems. And one more thing is that semantic meaning. Semantic meaning is missing. Now let me give you a very good example. Suppose I say the food is good, and I may also have another word or sentence which says food is not good. Now you know that this two sentence is quite opposite, right? But if we try to convert this into vectors, so my words will be something like this, right? Let me just remove, let's say these two sentences are completely different. Now, what I am actually going to say, let's take the most important vectors like food, good, okay? Food, good, and there is like is, not, and the. Let's say this many unique words are there. I think I have not missed any. Now over here, with respect to this first sentence, you will be able to see that what will be my vectors that will be available over here. Wherever food is there, so I'll write 1. Good is there, I'll write 0. Okay. Is there, I will write 1. Not is not there, so I'll write it as 0. The is there, so I'll write it as 1. Whereas in the case of this sentence, if I try to convert this into vectors, okay, what will happen over here? So food is actually there, as we are going to just write it as 1. Good is there. Sorry, good is also present over here. Okay, good is also present over here, so I'm just going to make it as 1. Here also in the second sentence, good is there. Is there. Not is also there, and the is also there. Now you know that these two sentences are completely opposite. You know, this is not at all similar. Not at all similar. But if I take this vectors and probably try to calculate the cosine similarity, okay, try to calculate the cosine similarity. So in this particular case, what will happen is that they will try to say that this sentence are almost similar, right? Because of these vectors. So right exact semantic meaning is missing. I'll not say right exact semantic. I'll not say semantic in this particular case, but at least you can see that the vectors are almost same over here, even though this sentence are completely opposite, right? So this issue needs to be fixed. And how do you fix this issue? By using TF-IDF. TF-IDF is nothing but term frequency and inverse document frequency. Okay, so I'll discuss about term frequency and inverse document frequency, but let's understand what did I actually say in this. Okay, over here you can see that both the sentences are completely not similar at all. Okay, but we are getting the vectors which are very much near to each other, because if you just try to find out the cosine distance between these two vectors, it will be very less, because there is only one value that is getting changed. Okay, now this is one of the issue. One more issue, let me tell you. Over here, either you are getting ones and zeros. Let's check in this sentences. Here, either you are getting ones and zeros, right? So you can understand that most of the words are getting the same value, like 1, because the value is either 1 or zeros, right? In this particular word also, this word is also getting 1 and this is also getting 1, right? So because of this, what will happen is that the real semantic meaning is not getting captured. In this entire sentence, which word should I focus more? Because over here, good is also there, boy is also there, and both are given the same importance, right? Both are given the same importance. Now you may be telling, Krish, why did you not remove the stop word? Okay, let's remove the stop word. Remove this is, okay, and remove the, okay, but not, don't remove it, because not can play a very important role. But in stop words, not is actually present. Okay, so you should create your own separate type of stop word so that this not should be captured over there. Now, if I remove this too also, then what will happen? This word or this sentence are almost similar, because this is 0, this is 1. Only one value or one vector is getting changed. Okay, so I hope you are able to understand the issues with respect to this. And here you can also see that when I try to find out the differences between these two words also, they are also given the same value or weightage. Okay, so we should try to give some importance to the specific words. Then how do we give it? So for that, we use something called as term frequency and inverse document frequency. Okay, so let me just go ahead and explain you about term frequency, and here we are going to discuss about inverse document frequency. Okay, now in term frequency and inverse document frequency, we focus on two important concepts. One is term frequency, okay, and one is the inverse document frequency. Okay, let me talk about this. Okay, let me take both the sentences which I have actually defined on the top. So over here, my sentence 1, after cleaning the text, I have got it as good boy, right? In sentence 2, I have got something called as good girl. Okay, in sentence 3, I have got something called as boy, girl, good. Right? So these are my 3 sentences that you can definitely see over here. Now, obviously you have seen how to do for the bag of words, right? But in this specific case, now what we are going to do is that we are going to basically calculate a term frequency and inverse document frequency. What exactly we are trying to solve? See, both these words are given the same weightage, like 1 and 1. We should not give this specific weightage. We should try to make sure that some of the words that are rarely present inside this document. Now, in this particular case, you can see that good is present in all the 3 sentences, but boy is actually present in 2 sentences. So boy should be given some weightage in sentence 1 and in sentence 3. Girl is present in sentence 2 and sentence 3. So girl should be given more weightage in sentence 2 and sentence 3, right? Whereas in good, since it is present in all the sentences, it should be given an equal weightage or less weightage. Okay, so we will try to convert this into term frequency and inverse document frequency. So in short, whichever words are rarely present in the sentences, we should try to give more weightage. Okay, again, remember this specific word, more weightage to the rare words that are present in sentences or this entire documents. Okay, so very much clearly I'm trying to explain you. So please make sure that you understand. Okay, and you will be able to understand this only when you clearly listen to me. Okay, now in this specific sentences, suppose let's say I have something like cat eats food. Okay, something, this is my first sentence, bat eats food. Okay, and probably Krish eats food. Okay, now here you can see that all the words are almost same, right? All the sentences are almost same. Now out of this, which is the rare word? Cat, bat and Krish. So this must be given higher weightage when we are creating the vectors. Okay, when we are creating the vectors. Okay, now always understand, I will go with respect to making you understand how we can make sure that these rare words are getting captured. These rare words will get captured by using this term frequency. Okay, and this common words will get captured by inverse document frequency. So when that both will get combined, when we combine both of them, then you will be able to see that we'll be able to find out the most rare word that is present in the document. So let me quickly write down the formula for term frequency and inverse document frequency and wait till the output is coming. Okay, once you will be seeing the output, there you will be able to see that how the differences will now come. Okay, so first thing, how to calculate term frequency. So here I'm just going to write the formula for term frequency. Okay, so the term frequency is basically defined as number of repetitions of words in sentence. Number of repetition of words in sentence divided by number of words in sentence. Okay, again understand, number of repetition of words in sentence divided by number of words in sentence. Okay, just keep this formula in your mind. And then inverse document frequency formula is log to the base e of something divided by something. This is nothing but number of sentences divided by number of sentences containing the word. By multiplying this two, I will be getting TF-IDF. Okay, now see this. First, let's go ahead and compute the term frequency. So here I'm just going to basically write the term frequency. Okay, so the term frequency over here that I'm basically going to write is sentence 1, sentence 2, and sentence 3. Let's say these are my sentence 1, sentence 2, and sentence 3. How many words I have with respect to the unique part? Here you can basically write good, boy, and girl. Okay, so these are my words and this is my sentence 1, sentence 2, and sentence 3. Now how do I calculate? Please everybody focus over here. How do I calculate with respect to the term frequency? Go and see the term frequency formula. Number of repetition of word in sentence. So let's go with sentence 1. Okay, now if I really want to find out the term frequency of good, okay, the term frequency of good, so number of repetition of word in sentence. So how many times good is present in this sentence? Okay, how many times good is present in the sentence? Only one. Okay, only one good is present over here. So this will be 1. If I really want to find out the term frequency of good, it will be 1 divided by what, how many number of words are there in the sentence? So here you can basically say that there are 2 words. Okay, so I hope everybody is able to understand. Okay, so 1 by 2. Okay, so over here basically says that good, how many number of words are repetition of words are present in the sentence? Only 1 time. And how many total numbers of words are there in the sentence? There are 2 times. Okay, so tell me about so good in sentence 1 is basically present 1 by 2. Okay, with respect to term frequency. If I try to compute for boy, so in boy, how many times number of words are present with respect to boy in sentence 1? Only 1. So 1 divided by 2, since there are 2 number of words. So here also I'm going to basically write 1 divided by 2. What about girl in sentence 1? What about girl in sentence 1? So over here you can see girl is not present. So I'm just going to write 0 by 2. So here I'm short, I'm going to get 0. Did you understand clearly everyone? Yes? Yes or no everybody? Now let's go with respect to sentence 2. In sentence 2, good is present, girl is present, right? So good and girl will be present. So boy will be 0. Okay. Good is basically again 1 by 2 because how many words are there? There is 2 words. So 1 by 2 is basically present. Okay. 1 by 2 is basically present. Okay. So now with respect to sentence 2, let's see. In sentence 2, boy is present? No. So I'm going to get 0. Okay. Okay, 0 over here. Now with respect to sentence 2, let's see with respect to girl. So girl is present, so I'm going to write 1 by 2. Okay, so this will be my 1 by 2. Okay. Now with respect to sentence 3, good is present. So here I'm going to basically write 1 by 3 because the total number of words that are present is 3. Okay. And similarly with respect to the boy, over here again 1 by 3. Again 1 by 3. So all these specific words are actually present with respect to sentence 3. Okay. So clear everyone? Yes. If it is clear, give hit like, heart symbol, something to motivate me. Okay. How do you motivate me? Okay. You can also give donations if you want. There is a thanks button in your YouTube channel, right? So please give that if you can. It'll be amazing. Anyhow, I'm distributing in quiz. So it is good that you give some thanks also. Okay. Okay. Now let's go and compute the inverse document frequency. Inverse document frequency. Okay. Okay. Now suppose if there was one more boy over here, what would be my boy in sentence 1? Can I say this should be like 2 by 3? Yes. If there is one more boy, so this will basically be 2 by 3. I hope everybody is agreeing, right? Yes. So very simple. So based on the number of words divided by the total number of words, repetition of words with respect to that. Okay. So right now it is 1 by 2 only. Okay. Now with respect to inverse document frequency. Now inverse document frequency, here I am just going to write two things. One is words and one is IDF. Okay. So over here I have good. Okay. What is the inverse document frequency with respect to good? Because words are how much? Boy and girl, right? Now inverse document frequency, this gets computed for every words. This term frequency is getting computed for every sentences. Okay. And this is going to be same throughout the any problem statements. Okay. So in that specific way. Okay. So here we go. Okay. Thank you for the super chat, Bhupesh Mahara and Kavya Basu. Thank you. Thanks a lot. Okay. So sometimes this kind of motivation is required, right? Now, how do I calculate for good? So good IDF basically means number of sentences divided by number of sentences containing the word. So how do I write over here? I will basically write log to the base E. How many number of sentences are there? How many number of sentences are there? There are 3 sentences, right? 1, 2, 3. Okay. So 3 sentences divided by how many number of sentences contains the word good? So go and see. Good is present in sentence 1, good is present in sentence 2, good is present in sentence 3. So 1, 2, 3. So it will be log base 2, 3 divided by 3. So this is basically going to be 0. Okay. So I hope everybody is clear. Now similarly with respect to boy, how many number of sentences are there? This is always going to be same. Log base 2, 3, log base 2, 3. Only divided will be changing. So how many sentences consist of the word boy? So here you can see 1 and 2. Okay. So 2 words are actually present. So I'm just going to rub this 1 and 2. Okay. So log base t 3 by 2. So here it is going to become 3 by 2 and 3 by 2. Okay. I hope everybody is clear. Yes. I hope you are able to understand this. Okay. Now what we are going to do now is that we are just going to multiply this 2. Now see what will happen. Term frequency multiplied by inverse document frequency it will become. Okay. Okay. Now final one you will be able to see that what we will be getting. First of all, let me write down the feature names. So it will be good, boy and girl, right? So this will be my feature 1, feature 2 and feature 3. Okay. Feature 1, feature 2, feature 3. Thank you, Parth Sharma, for the super chat. You're motivating me a lot. I can now take at least 4 to 5 hours classes, Then I will be having sentence 1, sentence 2 and sentence 3. Okay. Now see, let's go with respect to sentence 1. Okay. Sentence 1. What is the sentence 1 value? This specific value. Okay. Sentence 1. Okay. Now what we have to do for sentence 1 to find out good boy and girl, we will be multiplying this value with the IDF value. Okay, with the IDF value. Okay, with the IDF value. That is the inverse document frequency. Okay. Now everybody see, let's go ahead and multiply. For good, it will be for sentence 1 good. See, sentence 1 good, right? I've just traversed this. Okay, for sentence 1 good. Okay, so good, this will be 1 by 2 multiplied by 0. So can I write 0 over here? Okay, can I write 0 over here? Then let's go with respect to boy. So boy is over here. 1 by 2 multiplied by log 3 by 2. So here I will just go and multiply log base e 3 by 2. Then for the girl part, 0 multiplied by this value. So this is going to become 0. Okay. Now similarly with respect to sentence 2, I'm just going to take this vectors and multiply with this specific vectors. Okay. This specific vectors. So here what I'm actually going to do, I'm just going to multiply 1 by 2 by 0. So this is going to be, for good, it is going to be 0. Then this 0 multiplied by this will be 0. Last one will be 1 by 2 multiplied by log base e 3 by 2. But in case of sentence 3, we have all the values 1 by 3, 1 by 3, 1 by 3. So only the first one will be 0, since it is 0 over there. And then we'll multiply 1 by 3 log base e 1 by 3 log base e 3 by 2 and 1 by 3 log base e 3 by 2. Now see, one very super important thing over here. If you see over here, in this word, in this sentences, you can see good is a very common word, right? Good is also present, here also it is present, and here also it is present. Now if you go and observe in these vectors, do you see good is having all 0 values? Right? See, with respect to good, it is 0 because it is present in every sentences. So it is not playing a very big role. Right? It is not playing a very big role over here. Right? It is just playing a normal role. Right? But since good is present in all the sentences, it is saying the vectors to not give importance to that specific good vector. Okay? So you have just assigned it to 0. Now boy is present rarely in two sentences, over here, and over here. Right? Over here. So I have to give some importance in these two sentences to boy. So here you can see some value is there with respect to boy. And similarly in girl, you can see that girl importance is there in two sentences, this and this, right? So here you can basically see girl has some value over here, right? So now through this, you can see that some amount of semantic information is getting captured, right? Some amount of semantic information is getting captured. Now you can distinguish words that are frequently present and words that are only present in a specific sentence, okay? So here you can basically see all these things. And this is how we convert this entire words into vectors. At the end of the day, you can see that there will be one output vector, right? Because if you are solving a text classification or any kind of classification. So this becomes our entire data set and we can train our model over here. Okay. I hope everybody is able to understand. Yes, yes, yes. Can I get a quick yes? Yes, everyone? Yes. If you are liking the session, please do hit like. Okay. Please do hit like. Okay. Perfect. So this is how we can basically use term frequency and inverse document frequency to basically, solve this, convert words into vectors. But again, if I talk about advantages is that yes, intuitive, it is a bit complex to, implement TF-IDF, but it is intuitive and simple. But if I talk about disadvantage, here also, if our vectors are very big, sparsity issue is there. Sparsity issue is there. Yes, it is reducing when compared to the bag of words. But over here, the main advantage is that word importance are getting captured. Word importance is getting captured. Okay. With respect to disadvantage, there is again an issue of out of OOV, out of vocabulary. This is not getting handled over here anyhow. Okay. But just understand that here you can basically find something, okay? Some issues definitely, okay? So disadvantage, this is there. Out of vocabulary is also there, okay? Word importance is getting captured. This is the most important thing, and because of this, it can really perform a better role, okay? And again, these are some of the things, but yes, in the upcoming classes, we'll learn about word to vec, so it will be a definitely good situation, okay? So yes, till here, I hope everybody is understood. Shall we do some practicals? Okay. So let's do some practicals. Anaconda. Let's do, I'm just going to open my Jupyter. Wait. CD NLP. Jupyter notebook. Okay. And probably you can do whatever. I think everybody has got the materials, right? Everybody has got the materials? Yeah, from the dashboard that is given in the description of this particular video. Thank you, Subrat Patra. Thank you. So yesterday, I think we were doing this, right? We did this, right? How many of you did got the materials? Yeah, from the description of this particular video, right? So again, I will quickly execute this. If you have this material, no, IP1B is uploaded, guys. See, I will show you. Go to the description over there and open this community session. Let me sign in. All the materials are present. Yaar, aisa mat bolo. People will not even try to check. And they'll say, no, did not get. Okay, cry babies. Everything you want, but you will not go and see to it, okay? This is the most things, right? See, day 2, day 3, everything is there. See, resources are there. See, go and see the class materials. Everything is uploaded. But people don't want to do it because people are very lazy. So hats off to the people who are lazy. Claps, guys, for all the people who are very lazy, who do not check out the description, everything. Okay, so just check out in the resources, right? Resources. Okay, so let's quickly do it. So let me just revise whatever things we have actually done yesterday. Okay, glove also I will try to teach you, don't worry. Okay, so here is the paragraph. Then what is the use of Porter stemmer? What is the use of Porter stemmer? Quickly, this may come as a quiz to you also in the upcoming quiz competition. Tell me, what is the use of Porter stemmer? What is the use of Porter stemmer, guys? For stemming purpose, we basically use it, okay? Yeah. For stemming purpose, we basically use it. So here you can see, if you sent tokenize, then basically we are converting paragraph into sentences that I showed you. Porter stemmer is basically used for the stemming purpose. WordNet lemmatizer is basically used for the lemmatization purpose, right? So we all discussed about this, right? Now, what is this entire code doing over here? What is this entire code doing? Can anybody tell me? What is this entire code basically doing? So in short, we are taking the sentences, we are removing all the special characters other than, tell me what we are doing exactly over here. Other than A to Z and capital A to Z, remove everything, remove all the special characters because I had copied that entire text from Wikipedia, right? So sentences of I, and then we are basically using this and appending it. Still, we have not applied this. So this is how my corpus will look like. Okay. So this is how my corpus will look like. So here you can see this entire corpus, and or you are basically removing all the spaces and everything. If you write stopwords.words of English, here you will be able to get all the stop words. So one question I had asked in the last quiz that which all of these words are stop words, right? So there are many stop words. There is one stop word which is like don't, not, right? Not is also there. So I always suggest that you create your own stop word, okay? Based on some of the words that you don't really want to put over here, okay? Now, let's go and try to do something like stemming, right? So what does word tokenize actually do? It converts the sentences into words. So for a words in words, you can see I'm just checking whether it is a stop word or not. Otherwise, I'm applying stemming. Okay, so this specific code will actually do that. So whatever sentence or words that you will basically be seeing, here you are actually seeing that, okay, it has got stemmatized. Okay. Now, similarly, with respect to lemmatization, you just have to use lemmatizer.lemmatize. Okay. So here it is. Now here you are going to get a good work. Now see, we'll go step by step over here. First of all, we'll apply stop words, remove all the words, lemmatize. We are going to do. So first of all, I went and read all the sentences. I removed all the special characters other than A to Z and capital A to Z. Okay. And then we went to do review.lower, review.split. We did, right? When I do review.split, that basically means I'm going to get each and every sentences. And then here you can basically see that I'm applying for each and every words, and I'm basically finally I'll be able to get the corpus. I don't think so. Let's see how much is the corpus. So here you can basically see the corpus is available. Okay. Okay. Everyone clear? Okay. One thing that we did not do is that I had to write something like word tokenize. Okay. Not a problem. We'll do it. Okay. So let me do one thing now quickly. Okay, bag of words, TF-IDF. I'm just trying to open a code so that I can show you what exactly we are trying to do. Okay. Okay. So for word in review, if not word in this set stopwords.words, I'm going to check and basically I'm appending it. So by this way, you'll be able to see that all the sentences will be lemmatized. Now this is specifically the code for bag of words. So for bag of words, what is the function that we use? We use something called as count vectorizer. Okay. Apart from this, if I say count vectorizer, there are also something called as vectorizer. Okay. Count vectorizer scalar. Okay. Now in count vectorizer, you have some amazing parameters like ng gram range. Okay. Now see the power of ng gram. Okay. Now everybody focus on the power of ng gram. If I use ng gram over here, okay, like ng gram range, and if I write 3,3, so that basically means it is just going to create the trigram. Okay, 3,3. So if I execute and if I execute the fit underscore transform or corpus, now if you go and see the vocabulary here, you can see Narendra Damodar Das Modi. Okay, Damodar Das Modi Gujarati end, right? So here you can see listen born September Indian. So everywhere you will be able to see that there will be only trigrams. Okay. So if you're probably using this ng gram, so here you can definitely see that there is only trigrams, nothing else, right? But now if I write 2,3, so it is basically going to consider both bigrams and trigrams. So here if I execute this and if I execute this sentences also, and this sentence is also, so here you can see that it will start with bigram, Narendra Damodar Das Modi Gujarati, like this, Indian politician. So after you complete 2 entirely, then you will be able to get trigrams. Okay, everybody clear? Good enough. So from the vocabulary you can definitely see all the indexes of the words that are present. Okay, and now if you probably see corpus of 0, and if you try to see the output will look something like this. Okay, for the first one. Okay, so how do you verify? Just go and see which index is matching to which index. Okay, it's a very simple. And this many features, just imagine. Now this is the problem of sparsity, right? This is the problem of sparsity, which is really, really bad. Okay, now let me try to do the same thing for TF-IDF. So here now I'm going to just write down a comment and basically say that, okay, let's go with TF-IDF. Okay, so for TF-IDF, I will just go to write from sklearn dot feature extraction dot text. I'm going to import another library which is called as TF-IDF vectorizer. Okay, so here I'm just going to write TF-IDF vectorizer. Okay, in TF-IDF vectorizer also you have nggrams and all, you can apply for it, but here I'm just going to write cv dot fit transform, and here I'm just going to write corpus. Okay, so once I execute this, if I probably now see corpus of 0, okay, and if I probably see x of 0, here you will be, and try to convert into an array, to array. So here you will be able to see, do you see different values? In each and every sentences you can see different values. Sorry, in this sentence you can see 0.1966, 0.2523, 0.25. So this vector that is getting created, right? Okay, that is getting created. Here you can basically see that different values are coming up. Okay, everybody clear? See, whatever I have done, simple. I've just used TF-IDF vectorizer. Okay, and then based on that you will be able to see. Okay, everybody clear? Yeah, so here you can see 0.25, 0.178, 0.216. Obviously the feature is basically coming from here. You can definitely check it out, all the features from here. Okay, so if I probably try to see over here whether bigram and trigram are also present or not, just go and press shift tab. Here you will be able to see somewhere you can see vocabulary is there, bigram, trigram is not available over here. It should be, right? TF-IDF. Okay, so if I go and see TF-IDF vectorizer, nggram is there. See, nggram 3,3. So I can basically also use this and write over here. And let's say I want just trigram, then I can execute this. So with respect to trigram, you can see that I'm getting a different words, right? And there are also chances that different vectors may get the same thing because the frequency is almost same. Okay, suppose I want 2,3, then it will be somewhat more different. So here you can basically see different things are available. Okay, but again I want to try with 1,1, then I will be getting some more different values. Okay, there is also one amazing feature. Okay, now just imagine, guys, if I have this specific words with some frequency, right? Let's say let me define something like this. Suppose I have word like frequency, like good it's 10 times, boy is 7 times, and probably you may also have words like girl 6 times, toy 5 times, and like this I have a lot of features. And let's say after one specific feature it is less than 3. Okay, so we can also make sure that we can put this count also. Okay, so how do I put this count? So there is another feature over here which says max features. If I say max features as 3, let's say, so it is going to consider all the words that are at least present 3 times. Okay, so here I'm just going to basically use this like this, max feature is equal to 3. So that basically means unless and until it is not present, that many number of features are not present with respect to any words that are present over here. Suppose this full-time worker, if it is only present for 3 times, then only it is going to get used. Okay, so here we can also use this specific parameter and we can reduce the vectors. Now you can see that the vectors have got reduced, right? Vectors are getting reduced, right? So this max feature, let me just show you over here. I think, if not none, build a vocabulary that only consider the top 3 max features. Top 3 max features ordered by term frequency. Okay. Top 3 max features. Suppose I want just the top 3, then I can actually be able to get it. Okay. Okay. So here you can basically see that if I use top 10 max features, which are the top 10 occurring max features, based on that also I can basically do it. So I'm just going to write it over here as saying that, okay, I want just start the top 10 and execute it. I'll be able to get the top 10 vectors. Okay. Everybody clear with respect to this? Okay. One super assignment for you. Shall I give you one assignment? So again, I'm going to say you, if I write max feature is equal to 3. So what it is going to do, it is just going to pick the top 3 high element occurrency or high frequency elements or high frequency features. So in short, if I say max feature is equal to 3, whichever is the top 3 highest occurring frequency, I'm just going to consider that. So it will be good, boy and girls. So in short, you will be getting a vector of dimension 3. Okay. Okay. And this is very much important, guys, because there will be some words that will only present one time, right? That will be present one time or 2 times or 3 times, right? So it is always good that we take the top maximum number of words or highest occurring words that are present in the entire corpus. Okay. Everybody clear? Okay. Assignment time. Go to Kaggle. Don't go to Kaggle otherwise. UCF repository, UCI repository. Go and pick up any data set that you want. Go and probably see text data set. Text classification. Text classification. Go and search for it. You'll be able to get a lot of data set over here. Try to do something on that. Okay. So if I see a test data set here, you can basically see Asian religious data set. Just try with this. Take up any data set that you want. Try to apply all these things. So this will be an assignment for everyone. So assignment time, right? Unless and until you don't do assignments, you will not learn. So assignment is that take any data set, any text data set. I don't want to create model right now. Okay. Take any text data set, apply bag of words, apply TF-IDF, apply ng-gram, and just apply on this specific data set and just try it out. Okay. Just try it out. Okay. Just try it out. All these things, and after you do it, just drop me a mail at krishnaik06@gmail.com. After doing your assignment, just drop me a mail send your assignment to me at this specific mail. Okay. I'll have a look, and based on that, because we need to learn a lot of things, right? So did you like today's session, everyone? Yes. So in the next session, we will focus on word2vec. We are going to learn many things in word2vec. First of all, we are going to see what is embedding layer. What is embedding layer? Second topic that we are basically going to see is word2vec. Word2vec has 2 different things. One is CBOV and the other one is skipgram. We're going to check it out. Then I'm going to basically discuss about the architecture of word2vec. Okay. Then we are going to solve practical problems. And then I also want to take one topic which is called as glove. Okay. So this entire thing will get completed in the next week, Monday class. Okay. Not on Saturday and Sunday. Okay. Saturday, Sunday, I have to take classes. Okay. So all the 7 days I will be teaching. Okay. So CBOV, skipgram will get completed. And then we will be doing something called a spam classifier. A lot of different examples we will try to. Okay. So everybody ready for the quiz? What is the differences between 2 max DF, min DF? अरे यार search कर लो ना. What is so big in that? Min DF, minimum DF, minimum DF. Go and search for it. When building the vocabulary, ignore terms that have document frequency strictly higher than the given threshold. Simple है ना? Yeah. Label to vec also I'll try to convert. Okay. LBL vec. Okay. Okay. So quiz time. Everyone, go ahead for the quiz. Here we go. Okay. First step. Follow me in Instagram, and today I will also be requiring your ID card. Okay. Today I'll also be requiring a okay. So everybody quickly do it. 396 people are there, but do it, yeah. And please follow me in Instagram and drop me a message over there. Follow me in Instagram so that you can send your ID card. I require an ID card also. So keep your ID card ready and drop me a message. Okay. I require an ID card. Whoever is coming first, I will be able to check from that. Okay. I will start the session in some time. But please make sure that you follow me. And whoever wins, please send your ID card later on. Okay. But please make sure that you follow right now before we start so that I can validate and cause you. Okay. ID card basically means any ID, driving license, anything, so that I can validate it's your, because many people are editing and saying that I am the first winner. Okay, Insta ID I have given over here, Krish Naik 06. Just search for Krish Naik 06. Okay, search for Krish Naik 06. Okay. Krish Naik 06, everyone. Just search for Krish Naik 06 and just participate for right now. Okay. Okay, guys, just one request. Subscribe to my Krish Naik Hindi channel also. Please make sure that, because I'm also uploading videos in Hindi channel. So please make sure that you subscribe to that. Okay. Okay, 207. Why less number of people are joining? I want 399 people are watching. Come on, quickly. Okay, I'll also try it from my end. Server is not that slow. Your internet may be slow. Okay. So search for Krish Naik. Quickly follow me in the Instagram so that the score that you will be able to see and prize I will be able to send you through Google Pay. Okay. So should I participate in the quiz? Menti.com. Right. 6661385. Okay. So I have also joined. I'm also giving the heart symbol. Okay. So we will just start in some time. I want people to join quickly. 232 people have joined only. Why? Join quickly, no? 243. Just go to this particular URL, menti.com, and type the code 6661385. Yes. I am also participating and I am also competing for the first prize, 2000 rupees. Okay. In the dashboard, you will be able to see the resource folder. There you will be able to find it. Okay. Perfect. More 261. Come on, guys. Join quickly. Join from your mobile phone. Join from somewhere. Okay. Join, join, join. Join quickly so that we can start. Once it crosses 300, I'll start. Guys, quickly. We have started the session. Now people need to join. You are not supposed to participate, right, Krish? I'm not participating. I'm coming to give right answers to see everything is working fine or not. Do you pay PayPal? Yes, I'll also pay PayPal. It's stuck on Insta like page. Okay. Okay, do one thing. Just follow me in Instagram so that at the end of the day, I can message you from there and validate each and everything. Okay, guys, come on, join fast. Another 1 minute I'm giving you. Then I'm going to start. Everybody ready? Okay, let's go with the name now. Go ahead and write your name. Everybody's writing your name. Yes, everybody's writing your name. Okay. So here we are going to start. And here comes the first question. NLP can be used in. So I have answered it right this time. So you just have for 15 seconds quickly. Time's up, everyone. So yes, 20 people have said wrong. 21 machine learning, they have said none. 278, good, very good. People are saying it right. Okay. And I hope everybody wins this. It's a very easy question. Come on. Okay. So coming to the second question. Okay. Here we go. In your screen on your face. What is the process of turning a different morphologies of a word into its base form? I'm writing a wrong answers. So here you have another 15 seconds quickly. And here we go. Time's up. 207 people have said the right answer, 51 wrong. It is lemmatization, guys. Okay, so I've just used some different words to confuse you, but I think this was the first question that I had actually asked. So if you're liking the session, please hit like. If you want to also give some money so that I can distribute to people, please hit super chat, super chat, thanks. Something is there, no? How things will go. I have to take that money and give it to you all, Come on. So please hit like. Let's complete it to 400. Yeah, having fun? How many of you have said wrong answers till now? Both are wrong. How many of you have said both right? Or tell me like that. Okay. So come on, hit like, make it 400 before we go to the next question. Okay, here comes the first reward. I think Sonia Agarwal is in the first position, right? Anmol Soin is in the second position. Raja Varun Kurapati is in the third position. So Sonia, congratulations. Still there are a lot of questions. I hope you stay in this way and participate in a proper way itself, right? Let's go. My rank is 935, guys. See, I have proof. Okay. Now let's go to the next question, everyone. And here we go. How many trigrams is in subscribe to Krish Naik YouTube channel? Trigrams, how many? How many trigrams in subscribe to Krish Naik YouTube channel? So I've given 30 seconds for this answer so that you can think and probably answer. Amazing. Let's see how many people may have said right. Amazing. 199 people have said 3. This is absolutely right. Subscribe to Krish is 1. 2 Krish YouTube is 2nd. Krish YouTube channel is 3rd. So have you subscribed? Have you subscribed or not? Hmm? Come on, subscribe. Subscribe. Then only you'll be able to say right, no? Amazing. So 199 people have answered it right. Let's go to the next question. So hit like, then only do you want more complex question or easy question? Hmm? Let's go to the next question. Question number 4 in front of you. What is a high frequency? Which is a high frequency and low document frequency? A low weight in TF-IDF, a high weight in TF-IDF. I think many people will say wrong in this because this is a little bit confusing things, Which is a high term frequency and low document frequency? A low weight in TF-IDF, a high weight in TF-IDF, a bag of words, a document. I have clearly mentioned in today's class a high weight in TF-IDF. Okay. So 160 people have said right. It's going on amazingly well. I hope. Now let's see the rank board. Okay, Sonia Agarwal is still in the topmost position or what? No. So now we have again Sonia Agarwal. Let's see what is my rank. My rank is 2752. Oh my god. Sorry, 70th place. My rank is 70th place. Okay, I'm coming towards first rank. Let's see. So Sonia Agarwal is in first, Anmol Soin is second, Raja Varun Kurapati is in third. Okay, amazing. So hit like, okay, and obviously for the people who are just participating for the first time. Okay. So here we go to the next question. The fifth question. And here we go. Which of the following algorithm is widely used for text classification? So here we go. Decision tree, support vector machine, naive Bayes, all of the above. I know many people will basically say this as wrong. Let's see. Let's see who will be saying it the right answer. So 6, 5, 4, 3, 2, 1. Many people will be selecting naive Bayes. I knew that. All of the above is the right answer, guys. You can use decision tree, you can use support vector machines, you can use naive Bayes, whatever algorithm you want, you can definitely use. Because at the end of the day, you are converting a text into a vector. So every machine learning algorithm will work. Okay. Perfect. So I can see many people are saying wrong answers. Definitely you cannot come first by saying so many wrong answers. Final question onto your screen. And before we end this session, okay, let's go ahead. And gradient descent, Adagrad, Adam. What are these? Loss function, optimizers, regularization, none. This is somewhere out of NLP. Oh, it is in NLP only, in deep learning. But yes, it's fine. Loss function, optimizers, regularization, none. Yes, many people have actually said it as optimization. That is the right answer. Now let's go to the leaderboard. And probably I will be knowing who is the winner. Sonia Agarwal is still in the topmost position. This is awesome. So Sonia Agarwal has won first. Anmol Soin has second. Adarsh as third. So Sonia, please make sure that you ping me in Instagram. Congratulations to the winner. Congratulations to the winner, Sonia Agarwal, Anmol Soin, Adarsh. You can drop me a message in Insta along with your government ID. Okay. I'm waiting. Anmol Soin, Adarsh. Amazing winners. Come on, Anmol Soin. Oh, okay. One person says rank improved. Amazing. Congratulations. 3575109. Come on, guys. Why you are not sending me the information? 91. Where is Sonia Agarwal, Anmol Soin, and Adarsh? They're not dropping me a message. Why? People are not okay. 40 rank. Okay, just ping out all your. Okay, I've got Anmol Soin message. Anmol Soin will basically be getting 1500. Anmol, UPI ID along with your ID proof. Okay, perfect. I've also got his ID. So he's basically from Lovely Professional University. Okay. What about others? Anmol Singh, I'm just sending you. Just send me your email ID. Okay, this is there. I've got his information, UPI ID. So he is basically second. So I'm going to send him 1500 rupees. Okay. Guys, you can improve. That only I said, right? Now it will become tougher. So Anmol, I'm just going to send him 1500 for quiz winner. Sonia Agarwal, you can drop me a message. So Anmol, I've sent the money. You can check it out. So I have dropped a message. Adarsh. Okay, Adarsh, please send your screenshot. Okay. Please send your ID also, Adarsh. Adarsh, please send your ID. Otherwise, it will be difficult for me. Adarsh, please send your ID. Adarsh, please send your ID. Sonia, please send me your info. Only the first rank has not sent me any info right now. No class tomorrow, guys. We'll be having the class on Monday. Okay. Sonia, I don't know where Sonia is, but she's not sending me. Hmm? Okay, I've got Wealthy Vivek Adarsh. Perfect. So Adarsh is getting 1500. So I've sent Adarsh to you also. Just have a look onto the phone. So I've sent him also. Perfect. Sonia is remaining. Let's see whether she'll message me or not. Sonia message I have not got. This was it from my side. Please keep on rocking. Don't forget to subscribe Krishna Hindi channel, Krishna channel, and don't forget to follow me in Insta so that next time, whenever you're participating in the quiz, we are going to have more amazing things. Okay. And yeah, this is it. Thank you. Bye bye. Hello. Yes, I'm audible. So thank you guys. This was it from my side. Bye bye. Take care.